Okay, hello. Here's my latest, not greatest, and late homework assignment. Trying to do the amplitude analysis by FFT and then resynthesis by FFT. So quickly, I'll show that the pretty basic local peak amplitude detection that I implemented works up to a certain point. Basically, I'll show that depending on how many frames that we have, which we can get. Ooh, that's pretty, isn't that? Okay, so up here we can see our frame rate and our, more important, frame size. Okay. That there will be a certain amount of peaks that we'll need to track in order to represent the full spectrum. Perhaps we want that many, perhaps we don't. Improvements in the future will be perhaps to try to make that adaptive, so we don't need to choose, but it is able to kind of gain the full spectrum first and then refine it afterwards by additional peaks. And then I'll show the problems I'm having actually when I try to resynthesize the sounds. So what I am able to do, still with some error, is to resynthesize using the original phase and amplitude, the imaginary and real signals of the original sound. So that by using that, we can reconstruct with some kind of error. I'm not sure why. However, when I try to not rely on any phase information, but just the magnitude, and using trying to implement the additive synths from class, I get some not so great results. And so let's have a look. Okay. All right. So first is the ability to detect some frequencies and the up to the Nyquist spectrum. And I'll start with the lower order and then move up. So let's start with something like 10. Okay, so here we have a oscillator running at 330 hertz and then one at 600. Okay. You can hear a little jagged kind of artifact sounds. That's the reconstruction. Even though using the original phase, I'm still getting some unpleasant stuff. Let me add in some noise. And you should see now the limit of the range we're able to detect. And so we need to have about, at our rate, 60-something peaks just to get the entire frequency range in there. All right, so that is that. Things get worse though when I use the reconstructed signal from a random phase approach combined with what I thought the starter code was in MATLAB. This is what happens. So it seems to really just kind of be stuck in a bin. I can't quite capture the phase between successive windows, and therefore it just kind of vibrates between bins when it's in a frequency that lands in both bins, different bins. So try to prove that somehow. Anyways, sorry. Thanks.